Variables. A variable is a measure of an attribute or characteristics whose value can change. So we deal with a lot of different kinds of variables in our daily life, and we are surrounded by different kinds of variables. For example, your age is a variable because it's changing every day. In economics, variable is a very important concept because in economics we deal with different kinds of variables such as price, quantity, income, wealth, GDP, and so on. All these measures are variables in mathematical term. Right? Usually we use different kinds of symbols like X, Y, Z, or other symbols from Greek alphabets to describe different variables. We will be doing and using different kinds of variable notation in this course. Equations. Equation describe different kind of relation between variables. For example, your income may depend on the years of education and your work experience, right? So for example, we can describe income by variable y and your years of education by variable x and your work experience by variable z. And suppose that this relation can be expressed by using this following equation: y equal to 5 plus 2x plus 3z. By the way, this is a hypothetical equation, right? Don't believe what it's telling you. It's just an example. Okay, so this equation is showing us how variable y is determined by not only by variable x but also by variable z. For any equation with two variables, we can always find a graph that represents the equation. An equation can be either a linear equation or a nonlinear equation. The difference is that the graph of a two-variable linear equation will always be a straight line, but the graph of a nonlinear equation will not be a straight line. In this course, we will mainly be dealing with linear equations. So let's now get into the details of linear equations. A linear equation can have any number of variables, but the identifying characteristic of a linear equation, I think you know this already, is that none of the variables in a linear equation will have any exponent. For example, in this linear equation, y equals to negative 2x plus 10. As you can see, neither x nor y has any exponent. So this is an example of a linear equation. In general, a linear equation has the following form: y equals to mx plus c, where m is the slope coefficient and c is the intercept coefficient. We'll get into the details of these things later. What do these m and c mean? But for now, let's just understand that this is the generic look of a linear equation. We can find different combinations of x and y that satisfy a linear equation such as the one we have written above. The easiest way to find different combinations that satisfy a linear equation is to plug in different values for x on the right hand side of the equation and then find out the corresponding value of y. Right? For example, take this same linear equation that we have already seen. Right? Now, if in this equation, if you plug in x equal to 1, right, then you can find out the corresponding value of y. Okay, so if you substitute x equal to 1 into this equation, you will find that y is equal to 8. Right? So this combination of x value and the y value describes a particular relationship between these two variables which is described by this linear equation that we are talking about, this particular linear equation. Now, if you substitute a different value of x, for example, if you substitute x equal to 2 into this equation, right, and simplify, you will find that the corresponding value of y is 6. So this is another combination of x and y, x being equal to 2 and y being equal to 6 is another combination that satisfy this relationship described by this equation. Notice that the slope of this equation here is -2. The value of m, this m is -2. So that's why the slope is -2. We will discuss later what does the value of a slope mean to us. For example, in this particular equation, linear equation, when the slope is -2, what does it mean? We will discuss this thing later. Now please go through this exercise and match your answers to the answers I have given. Okay, now let's look at a situation when we have more than two variables on the right hand side of an equation. For example, if you look at this equation, y equal to 5x1 plus 3x2 plus 10. So you see that there are two right hand side variables, x1 and x2. So the value of y depends not only on x1 but also on x2. Now, to find out different combination of values for these variables that satisfy this equation, we can do the same thing as before. We can plug in different values of the right hand side variables to find out the corresponding value of y. For example, if you substitute x1 equal to 1 and x2 equal to 1 into this equation, right, what do you get? Okay, take a minute to calculate this. Okay. x1 equal to 1 and x2 equal to 1. So when you substitute x1 equal to 1, this term is 5. When you substitute x2 equal to 1, this term becomes 3. So 5 plus 3 plus 10, so 18. So the corresponding value of y will be 18. In a similar manner, you can substitute different combination of values for x1 and x2 on the right hand side and find out the corresponding value of y on the left hand side of this equation. Another thing that I would like to discuss in this context is how different variables on the right hand side affect the value of y differently. For example, in this equation we have two right hand side variables, x1 and x2. Notice that they affect the value of y differently. For example, if you increase the value of x1 by 1, the value of y increases by 5. So that's what this 5 is telling us. On the other hand, if you increase the value of x2 by 1, the value of y will increase by 3 this time. Please check to make sure that you understood what I just described by substituting different values of x1 and x2 and then increase or decrease the value of x1 or x2 by 1 while holding the value of the other one the same and see how the value of y changes.